What if the universe didn't whisper this time, but screamed? Astronomers monitoring an otherwise silent patch of sky suddenly witnessed a violent spike of radio energy blasting through their instruments, a spike so sharp, so precise, and so impossibly distant that the team refused to believe it was real. They tore the system apart looking for loose cables, software glitches, even interference from passing aircraft. Nothing. The signal held steady. It wasn't Earth. It wasn't the Milky Way. It came from far beyond, from a region of intergalactic darkness where no large galaxy is known to exist. And the strangest part? This wasn't the first time something like this happened. Years ago, another deep space radio anomaly appeared, a signal so unusual that one astronomer jokingly labeled the file WTF. Now, it seems the cosmos just sent us another one. But this new burst is different. It carries structure, fine details, internal flickers that rise and fall in rapid waves, almost like a heartbeat compressed into a millisecond. Natural objects can create bursts. Magnetars can erupt. Colliding stars can release shockwaves. But nothing fits the exact profile of this new signal, and when researchers plotted the burst on a dispersion map, the chart that shows how radio waves stretch as they cross unimaginable distances, the curve pointed to a staggering conclusion. This thing traveled billions of light years through the cosmic web, drifting past filaments of dark matter, clouds of intergalactic plasma, and the cold void that lies between galaxy clusters. Something out there, in one of the loneliest regions of the universe, just unleashed more energy in a moment than our sun will release in days. And that leads to the question no one wants to ask. What could possibly exist in a region so empty, yet be powerful enough to shout across the cosmos? I'm Alex McColgan, and this is Universe Decoder. Today, we'll dive into the newest cosmic mystery, a radio signal that refuses to behave, refuses to fit any model, and refuses to let scientists sleep, because the deeper they look, the stranger it becomes. To understand why this new burst has astronomers pacing around their offices at 3 a.m., we have to look at the signal's fingerprint. When a fast radio burst, an FRB, travels across the universe, its frequencies drift apart. High-frequency waves arrive first. Lower ones drag behind. This dispersion tells scientists how much gas the signal passed through and roughly how far away the source might be. For this burst, the dispersion wasn't just high, it was colossal. It places the source far beyond the outskirts of our galaxy and way beyond any satellite galaxy. And yet, when telescopes zoom into that part of the sky, they find almost nothing. No bright host galaxy, no star-forming region, just a thin stream of faint light, possibly a shredded dwarf galaxy stretched by gravity over billions of years. But the internal structure of the burst is where the real nightmare begins. Instead of a single clean pulse, the burst is composed of tiny subpulses, each separated by microseconds. It's like looking at a cosmic Morse code with no translator. Magnetars can flicker, but not like this. Supernova remnants can scatter radio waves, but not in these patterns. Even the strongest black hole jets we've modeled struggle to match the timing of the subpulses. So scientists turn to the oddest explanation on the table: gravitational lensing. If the burst passed near a massive object, a black hole, a rogue cluster of dark matter, or a faint dwarf galaxy, the radio waves could have split into multiple pathways, arriving milliseconds apart. That might explain the echo-like repetition recorded by one observatory. But if that's true, then the original burst is even farther away than the dispersion suggests, possibly billions of light years beyond the first estimate. And here's the kicker. When researchers scanned older data, they found a weaker precursor signal from the same coordinates, months earlier, with a slightly different dispersion. Something is changing out there. Something is moving, shifting, or interacting with its environment in a way no FRB should. And if it's repeating, astronomers need to figure out why. The team began searching for a physical source, something anything capable of producing these bizarre bursts. The most straightforward culprit would be a magnetar, a hypermagnetic neutron star capable of releasing catastrophic flares. But magnetars usually live in young galaxies with active star formation. This region shows none of that. Instead, deep ultraviolet scans reveal a faint haze, a ghost of a galaxy long dead, a place where stars burned out, exploded, and scattered their remains across intergalactic space. That led scientists to a chilling possibility. This might be an orphan magnetar, a neutron star ripped from its home galaxy and flung into the void by a gravitational catastrophe millions of years ago. Alone and drifting, its magnetic field could behave unpredictably, producing bursts with strange, uneven structures. Another idea is even more dramatic. Perhaps we are witnessing the aftermath of a collision between two compact objects, neutron stars or black holes, but in a region so stripped of matter that the merger's debris has spread thin across space. The remnant could be spinning rapidly, emitting radio beams that sweep across the universe like a lighthouse. But that raises a major problem. Mergers typically produce one burst, not several spaced months apart. So theorists began exploring the strangest corners of physics. Could dark matter be playing a role? Some models predict that dense clumps of exotic matter, when disturbed, could release enormous bursts of energy. Others propose cosmic strings, hypothetical relics from the Big Bang that could snap or oscillate, producing radio spikes when they kink. And then there's the idea no one wants to say out loud. Could this be artificial? An engineered burst, not a message, but a byproduct of high-energy technology. Maybe a beam used for propulsion. Maybe a navigation pulse. Maybe something abandoned and still operating long after its creators vanished. It's unlikely, but the waveform's structure is unlike any purely natural profile in current catalogs. Until more bursts are detected, every possibility stays on the table. And the universe has just started talking. So what happens now? Telescopes around the world have locked onto the coordinates of this strange burst, waiting for it to fire again. Each night that region rises, and radio dishes track the darkness, hoping for another spike. If they capture more, they can triangulate the exact distance, and that distance will determine everything. If the burst came from a nearby dwarf galaxy, the energy source could be extreme, but still within the realm of magnetars or black hole remnants. But if the burst is located in the intergalactic void, billions of light years beyond the nearest major cluster, something else is happening. Something unprecedented. And astronomers already have clues pointing in that direction. One observatory reported that the secondary echo from the burst had a different dispersion than the main pulse. That means the environment around the source is changing, or the burst is passing through turbulent plasma clouds that shift over time. Imagine a cosmic storm, a nebula of charged particles swirling around an invisible engine, distorting every signal that escapes. The profile of each burst would be slightly different. That's exactly what we're seeing, and if that's true, scientists might be witnessing the evolution of an extreme astrophysical object in real time. A newborn magnetar, a post-merger remnant, a black hole accreting the last fragments of a destroyed star. Or something new entirely, something we have no category for yet. And that is what makes this moment so exciting. For the first time, humanity isn't just staring at the obvious bright objects of the night sky, the galaxies, quasars, nebulae. We are detecting things that live in the shadows between them, signals from places where nothing should exist, and each burst is like an invitation to pay attention. This new WTF-style signal isn't just a mystery. It's a glimpse into a hidden layer of the universe, a layer that our telescopes are only now becoming powerful enough to detect. And if the universe really is trying to tell us something, it's that the darkness between galaxies is far from empty. It's alive with events we've never imagined, and we're only beginning to hear them.